Two wires AB and CD, each of 1 meter length, carry a total charge of 0.2 microcoulomb each and are placed as shown. The end B and C are separated by 1 meter distance. Determine the value of electric intensity at the midpoint P in terms of unit vector I and J. So see, first we need to know the formulas we have to use in these two wires. This is a finite wire where P is a point of the axial point. For axial point for a finite wire, the formula is K lambda by R 1 by R minus 1 by R plus L. That is the formula for finite wire on the axial point. For this point, there are two components. One will be the perpendicular component, which is perpendicular to wire. That is K lambda by R. And perpendicular component is sin theta 1 plus sin theta 2. And the one will be the parallel component, which will be away from wire because the wire is positive. This will be like this direction. So this will be given as minus I direction. This is positive also. This will be given plus I direction. And parallel will be like this. So I am writing the values already. E parallel, E perpendicular, and this will be E1 due to the AB wire. You can also write AB. K lambda by R cos theta 1 minus cos theta 2. Okay, and I am not concerned about the value here, direction or plus minus here. I know the direction will be in the left direction. Sorry, in the upward direction. So I'll write it as plus J and I'll take it as a mod. Okay, so these three things I have to calculate. If you can see, for every part K lambda by R is going to be same because lambda is same for both. Now what is lambda here? That is Q by length. Q is given as 2 10 power minus 7 I can write, and length is 1 meter. So already lambda we know. The R for both the values is same. For here R is also 0.5 and for here also I have 0.5. So this entire thing is same, and we can calculate also first of all. That is K lambda by R we can calculate. 9 10 power 9, lambda is 2 10 power minus 7 and R is 0.5 meter. So we get 9 2s are 18 and 18 upon 0.5 is 36. Okay, 100. 1800 and divide 0.5 3600. So 3600 is value for K lambda by R. Is there any calculation error? K lambda by K lambda is 2, fine. That is 1800 divided by 0.5 is 3600, correct. So we can simply solve these three brackets and then get the answer. The outside thing already been solved. So what is 1 by R and 1 by R by L? Minus 1 by R plus L. This is 1 by 0.5 minus 1.5. So I'll get 1.5 minus 0.5 is 1 upon 0.75. So I'm getting as 4 by 3. This bracket is solved. Now let's find sin theta 1 plus sin theta 2. Now one angle already is 0 because we take the angle from the edge and the point. From the line joining the edge and the point of interest, that from there we take the angle. So one angle will be 0, the other angle will be this. Okay, so this is 1 meter, this is 0.5. So you can easily find this angle using by sin theta. By Pythagoras first we can write it here. 1 square plus 0.5 square is 1.25. And then sin theta would be 1 upon 1.25. Okay. So one angle will be 0, that is 0, and the other will be 1 upon square root of 1.25. Approximately I can take it as 1.1. 1.11 square is 121. Slightly I'll take it as 1.12, and if I calculate, I'm getting very close to 0.9. Okay, approximation I can use 0.9. 1 upon 1.1 will be 0.9. This part is solved. The next part is cos theta 1 minus cos theta 2. We are not concerned about the sign. So 1 will be 0. So cos 0 is 1. Any angle you can take 0 because I have already told you it doesn't matter whether you write theta 1 or theta 2 before. So 1 minus and the other will be cos theta 2. This already been calculated. This is base 0.5 divided by 1.25. So already taken as 1.12. This can be written as 1.12 minus 0.5 divided by 1.12. This will be 0.61, 1.12. It is very close to, you can take it as 11, 5, 55, 0.55 I can take it as. So all the things I have calculated. So let's solve. This is, so this is minus I, na? So this I can take it as common, 3600, 3.6 10 power 3, and rest I'll write. Now this is 4 by 3i, 1.33i minus 0.9i, okay, because this is also I, and this is going to be plus j, the 0.55j, a very approximate calculation I'm doing. So I'll get 1.33 minus 9.9, sorry, 0.9, I'll get 0.43. So 3.6 10 power 3 into 0.43i plus 0.55j. Now let's calculate the things. 36 into 4 will be 36 into 4, how much? 144. So it is 3.6, so it will be 1.44. Okay, so 1.44 I approximately, not very exact values I am calculating. 1.44 into 3 plus 3.6 into 0.5 will be 1.9 approximately. So and n2 multiply by 10 power 3. Okay, so that is the answer to the question. So I'm giving the answer as 144, or you can say like I plus 1900J, somewhere close to it. If there is some calculation error, you may please check it, but because there are huge calculations here, but I think you have understood the method of solving such a question.